Welcome to this AQURON Adding Life Value presentation. We are going to look at how the AQURON 7000 system arrests corrosion of embedded steel and cost-effectively extends durability of reinforced concrete structures. As follows is a summary of the factors that influence and accelerate the corrosion of embedded steel in concrete. We are going to take a look inside a typical reinforced concrete marine structure. Firstly, we're going to have a look at moisture and how it gets there. The concrete matrix is made up of porosities, reticulation, and interstitial spaces. These three things all create the permeability factor of the concrete matrix. We must understand that there are three states of moisture in concrete. The first is chemically bound, part of the cement paste. The second is physically bound in the interstitial spaces. The first two cannot move. And the third is the free moisture moving in and out of concrete. And this is the transport system for corrosives. Concrete with exposure to the environment is subject to constant wetting and drying. Let's have a look at these different types of exposure. Rain, sea spray, and salt water are all forms of moisture that cause the constant wetting and drying in the environment. To understand the corrosion process, we must consider the primary components in the concrete matrix, their relation to embedded steel, and the effect of chloride contamination. Let's have a look at components inside concrete. Primary components of alkaline cement paste are calcium silicate hydrate, the binder of concrete, and calcium hydroxide. These two together create alkalinity inside concrete. Alkalinity with the ionizing solution of free moisture passivates the surface of steel. Passivation is the natural protection of steel. Let's have a look at how alkalinity actually passivates the surface of steel. The mass of the steel tends to have a positive galvanic potential, as you can see here. The positive charge on the surface of the steel attracts the negative oxygen atoms from the surrounding ionizing environment. As a result, we have passivation on the surface of the steel. But passivation varies, as you can see here. We are now showing you that the sites of minimal passivation is actually where corrosion starts. Corrosion is an electrochemical process. This process starts with ion flows between an anode and a cathode through the ionizing solution of free moisture. Ion flows start from the cathode and travel to the anode. And in reverse, a responding electron conductive contact starts through the rebar between the anode and the cathode. The anode begins by Fe ions dissolving into the ionizing solution. And of course, free moisture is the transport system for chlorides to reach these corrosion sites. Chlorides accelerate the corrosion process. Before we go any further, let's have a word about salt. In the solid state of salt, the chloride ions with the negative charge are held or bound to the sodium ions which have a positive charge. But this all changes when dissolved in water. The chloride negative ions are no longer bound to the sodium ions. Let's see how that accelerates corrosion. Free moisture is the transport system, and with chlorides becomes the electrolyte for corrosion. You can see here the positive galvanic potential of the steel is attracting the negative chloride ions. Then the ion and electron flows start up and accelerate the corrosion. Once there is sufficient chloride levels at the corrosion site, the corrosion accelerates quickly. AQURON adding life value solutions are the answer. AQURON is a spray-applied protection for new and existing concrete. Spray applied to the surface, AQURON solution has a molecular attraction to the moisture and alkalinity in the concrete, resulting in AQURON deeply penetrating into the concrete. How corrosion is prevented and arrested in an AQURON-treated concrete. Free moisture is transformed to be part of an extensive AQURON-induced hydrogel formation within the concrete matrix. In simple terms, as you can see here, the AQURON has stopped the moisture moving through the porosity, also stopping the transport system for corrosives. Another benefit is the AQURON hydrogel has high resistivity. Increasing resistivity improves concrete's natural resistance to corrosion. How AQURON purges contamination. Before AQURON treatment, chlorides are attracted to the positivity of the steel. As you can see here, the positive galvanic potential of the steel is attracting the negative chloride ions. This all changes with the application of AQURON and the hydrogel formation's positive potential. Negative chlorides are now attracted and chemically bound within the hydrogel. These bound chlorides are slowly repositioned to an equal concentration within the hydrogel and/or purged to the surface as shown here. This may happen over a period of time. Along with the natural environment washing cycles, these chlorides are further washed from the surface of the concrete. Passivation is increased with AQURON. As you can see here, the hydrogel working through the porosity also increases the natural passivation of the steel. Oxygen availability is also reduced. As shown in the treated versus untreated concrete, the oxygen can no longer move into the interior of the concrete. Stopping oxygen moving into concrete is stopping the fuel of corrosion. AQURON offers 5 major benefits. Free moisture is transformed to be part of a hydrogel, eliminating the transport system for corrosives. Chlorides are attracted into that hydrogel and repositioned or purged, stopping the acceleration of corrosion. Passivation is increased, increasing natural protection of steel. Oxygen availability is reduced, eliminating the fuel of corrosion. Breakout corrosion alongside repairs is prevented, i.e. the incipient anode syndrome. Useful service life of these structures is extended. What AQURON 7000 offers your structure is it penetrates, it purges, it protects, and it's proven to to adding life value.